this is Caitlyn again with Star Tutors. Today we're going to go through the AP Calc BC multiple choice exam from 2012. So right now in this video we're going to do the no calculator multiple choice questions. There's 55 minutes and 28 questions. And then in the next video we're going to do the calculator section of the same test, multiple choice. So there'll be 50 minutes, 17 questions. And so there's 45 multiple choice questions overall. This is half of the AP Calc BC exam. So 50% of your overall kind of score. The other half is all those free response questions. And so I just want to point out that this test is really kind of, you don't need to get a perfect score in order to get a 5. So a 5 is the max that you can get. You only really need 75% of the questions correct to get a 5, which is like in school, 75% would be a C. So note that we're not going to be shooting to get every single problem right. And in particular, I'm going to be going through this test and trying to get the problems that I know are going to be the quickest and easiest for me to do first. And then I'll go back through with whatever extra time I have and try and get those harder questions. And so my goal is going to be to get overall between the two multiple choice sections, which have 45 questions total. My goal is going to be to get a 30 on those, because then if I get a 30 out of 45 in the multiple choice, and I'm able to just get 5 out of 9 on average for each of the free response questions, that would give me a 5 on the test. It's a perfect score. So I have a timer here, and we also have someone over there timing to make sure that I'm not, there's 2 timers, and you'll see a timer in the bottom of your screen as well. We've got 55 minutes, 28 questions, no calculator, BC exam. So I think if you guys are ready, I'm ready. Let's do it. 3, 2, 1, go. All right, so the first page is always the same. Let's see, right off the bat, we've got a derivative question, our favorite. So let's see, I'm going to write in red. So taking the derivative, we've got 3 sine x squared, and then I have to remember chain rule to multiply by the derivative of sine, which is cosine. So I get dy dx is this, which I notice is e. Number 2, the position of the particle moving in the xy plane is given by parametric equations. Okay, so parametric equations, for people who are doing AB, this is a BC topic, but so this says, let's see, x of t is this, y of t is this, which of the following is the particle at rest? Okay, so particle at rest means that its velocity has to be 0. In this case, I have both kind of an x direction and a y direction, which means I need both the velocity in the x direction and the velocity in the y direction to be 0 if the particle is going to be at rest. So what I'm going to do is I'm going to take the derivative of x and y, each with respect to time, and I'm going to set those equal to 0. So I've got 3t squared minus 6t for the x derivative, and then dy dt, I've got 12 minus 6t. Okay, and so I want to know for which of these points is the particle at rest. That'll be a point where both of these would be 0. So let's see. If this is 0, the bottom one, I've got 12 equals 6t, so then t is equal to 2. So I'm looking for time equal to 2. I assume if I plug time equal to 2 into the x one, I would also get 0, hopefully. Let's see, we'd get 3 times 4 minus 12. Yeah, so that would be 0, so that's good. So I want to plug time equals 2 back into my x and my y to get my x, y point. So x of 2 is going to be 2 cubed minus 3 times 2 squared. So that's 8 minus 3 times 4 is 12. 8 minus 12, negative 4. So the x one is negative 4 already. There's only one answer with x equal to negative 4, so that's got to be it, A. Number 3, the graph of f is shown for 0 to 4. What's the value of the integral? Okay, so here we just need to know that the integral of this function, they don't even tell us what it is just the area under the curve, right? So I'm just trying to find the area under this curve between 0 and 4. So I'm going to split it up into these 2 different pieces. There's the part above the x-axis, and there's the part below the x-axis, I have to remember that the area below the x-axis is going to count as negative when I'm taking this integral. So first of all, we've got the integral from 0 to 2 is this area here. I'm broken it up into a rectangle and a triangle. So the rectangle's area plus the triangle area. The rectangle area looks like it's a 2 by 1 rectangle, so that's 2. Then the triangle, we've got the base is 2, the height is 4, because it goes from 1 to 5. So this is 1/2 base times height. Base is 2, height is 4. That gives me 2 plus 4, that's 6. And then I have to subtract the integral from, or I've got to subtract the area under the curve between 2 and 4, which is this rectangle. This rectangle has width 2 and height 1, 2, 3. So 2 times 3, that's 6. So this is negative 6. Okay, and then I have to add those. 6 minus 6, 0, b. Okay, number 4. Which of the following integrals gives the length of the curve? Length of the curve. Okay, so again, this is a BC topic. AP people or AB people won't know what this is. This is like either you remember the definition or you don't. I remember that the definition of the arc length is going to be you got to integrate from wherever your x's are going between. Then you have to do the square root of 1 plus the derivative. So let's see, dy dx all squared. Dx. So my derivative here is the derivative of natural log of x, which is 1 over x. So I need the square root of 1 plus 1 over x all squared, which is going to be a. Okay, so if you didn't remember that definition, you should skip that problem. I remember the definition, so I did that one first. Okay. Next, number 5, the Maclaurin series for the function f is given by f of x equals this. What's the value of f of 3? Okay, so again, BC topic. And we, so this is a BC topic. Maclaurin series is the Taylor series at 0. F of 3, we just plug in 3. And we see what we get. So we get n equals 0 to infinity, negative 3 over 4 raised to the n. Okay, so I notice that this is a geometric series, which luckily has a formula so that you can actually compute it. Geometric series only converge when the ratio that you're using has absolute value less than 1. And when that's true, so when you have the sum of r to the n from n equals 0 to infinity, it will converge to 1 over 1 minus r. In this case, we have r equal to negative 3/4, which has absolute value less than 1, so this will converge. And so we plug this in, we get 1 over 1 minus negative 3/4, which is equal to 1 over 1 plus 3/4, which is 7/4. So this is 4 over 7. Okay. Number 6. Using the U substitution. Did I click? Oh, I didn't circle an answer. Okay. Sorry. Go back. There we go. 4 seconds. Using the U substitution. So they actually tell us the substitution. That's nice. And then we want the integral from negative 1 to 4 of x times this. All right, so first of all, my U substitution, they want us to use x squared minus 3. And then if I take the derivative, du is going to be 2x dx. And then I just have to make sure I substitute everything in terms that is in terms of x right now. I need to substitute it all into terms of u. So in particular, I see in my integral I have this x dx. That means I need to solve for x dx in my expression for du. So I've got x dx. I would just have to divide by this too. So I get 1/2 du. And then this is just going to be u to the 5th. So I've got the integral of u to the 5th times 1/2 du. I'm going to write the 1/2 on the outside, 1/2 du. And then I have to remember to change my bounds. Instead of integrating with respect to x, now I'm integrating with respect to u, so I have to change my bounds. So what I do is I say, well, I started at x equals -1, and I want to know where my u will start. So I plug into this expression for u -1. So I have u equals -1 squared minus 3. So this is u equals 1 minus 3. U equals -2 is where I should start. And then again, you plug in 4 because for x, that's where you'd end. So you get u equals 4 squared minus 3. That's 16 minus 3, which is 13. All right, so, and then there should only be one answer that has that, which looks like C. Okay. Great. Number 7, arc sine. So we've got arc sine of x equals natural log of y. What's the derivative of y with respect to x? Notice that we don't have an equation that says like y equals something, which means this is going to be an implicit differentiation question. So I still want to take the derivative with respect to x of both sides. I just want to be extra careful when I'm doing that. So the derivative of arc sine of x, again, this is something you have to memorize. The derivative of arc sine, if I remember correctly, is 1 over the square root of 1 minus x squared. And then so that's the derivative of this left-hand side with respect to x. The derivative of the right-hand side with respect to x is going to be 1 over y times the derivative of y with respect to x. So that's that chain rule happening there. And now I wanted to solve for dy dx, so I just solve for that in my equation by multiplying by y on both sides. So I get dy dx is equal to y over the square root of 1 minus x squared. Okay, and it looks like that is answer choice A. All right, so we're 10 minutes in. We've done 7 problems. There's only 28 problems, so I think I'm moving fairly fast, which is good, but problems are probably going to get harder now. So let's see. Number 8. A tank contains 50 liters of oil at time 4. All right, so that's important. That's going to be our initial condition. Oil is being pumped into the tank at a rate, R of t, where R of t is measured in liters per hour. T is measured in hours. Selected values of R of t are given in the table above. Using a right Riemann sum with 3 subintervals and the data in the table, what's the approximation of the number of liters of oil that are in the tank at time t equals 15 hours? Okay, so this problem, there's always a problem like this on the AP Calc exam. It's not going to be that hard, but it does take some time and it takes some computation. So I think maybe I'm just going to set it up and then I might come back and like multiply it all out later. But so a right Riemann sum, what I recommend here, you have to plot the points. Just plot the points. It doesn't have to be super accurate. You just have to plot it, get a picture, see what's happening. So we've got 6.5 and then 6.2 and then 5.9 and then 5.6. So this is going down, and I've got my 3 different subintervals are going to be these ones. I don't know which, so then it says right Riemann sum, so that means I'm picking the intervals on the right-hand side. So I'm doing this, and I want to add up the areas of these rectangles will be my my approximation. So I'm going to have, I'm approximating the integral from 4 to 15 of this R of t, the rate at which the oil is being pumped in, dt. I'm going to approximate this by this right Riemann sum. And so that right Riemann sum is just the areas of all of these 3 different rectangles added together. So the area of the first rectangle is just going to be length times width. So the width is from 4 to 7, that's 3. And the height is going to be the value of the function, this was 6.5, this is 6.2. So its height is 6.2. And then the next one has width 5 and has height 5.9. And then the last one has width 3 and height 5.6. Okay, so I multiply those out and I add them together. Let's see, my mental math. 6, 18, 18.6 plus 5, 4, 25 plus 4 is 29 plus 8, 1, 50, 16.8, and then I add those together. Let's see, I'm going to write them up here. 14 plus 5 is 19. 1, this is 10 plus 14, that's 24. 4, 2, 3, 4, 5, 6, 64.9. Okay, notice 64.9 is an answer, but that's not the answer to this question, which is where they're going to try and trick you. Most people will probably pick 64.9. But what we have to do is we haven't even used at all that they gave us this initial condition of 50 liters of oil in the tank at time 4. So here we have to use the fundamental theorem of calculus, which says that this integral, I'll write it up over here because I don't have a ton of space, the integral from 4 to 15 of the rate of change of the oil is going to be equal to the amount of oil in the tank, the difference between the amount of oil in the tank at time 15 and the amount of oil in the tank at time 4. So maybe I'll just write that as, I don't know, O of 15 minus O of 4, where O is the actual number of liters in the tank at time t. And what did I want to do? I wanted to find the approximation for the number of liters of oil in the tank at time 15. So I'm trying to find this O of 15, and they tell me that this O of 4 is 50. And I've approximated this integral by my Riemann sum to be 64.9 equals O of 15 minus 50. So that means I need to add 50 to get O of 15. So I add 50 to get that. The oil in the tank at time 15 is whatever that plus 50 is, 114.9, which is answer choice C. Okay, that one was hard. That took a while. That took a few minutes. So if you didn't know how to do that problem right off the bat, yeah, definitely would be a good one to skip and come back to because it did take a while. This next one too, which of the following series converge? BC topic again. Convergent, like trying to show that a series converges often takes a really long time because there's like a ton of different tests, and it isn't always obvious which test to use. So I'm going to skip this problem and I'll come back to it. So I'm gonna star this, and remember, I need to come back to number 9. Okay, 10. Yeah, see, this problem is way easier. I'm gonna do this problem next. Integrate. So we've got the integral from 1 to 4 of t to the minus 3/2. Power, reverse power rule. You add 1 to the exponent, so that's negative 3/2 plus 2 over 2, which is negative 1/2, and then I have to divide by, so I do 1 over negative 1/2. Ignore that minus sign. T raised to the negative 1/2. Whenever you integrate, guys, you can always check it by just taking the derivative quick and making sure that works. If I took the derivative, I'd bring down the negative 1/2, it'd cancel, and I'd subtract 1 from the exponent, and I'd get the same thing back. Then I need to evaluate this from 1 to 4. So this 1 over negative 1/2 simplifies to negative 2. So I have negative 2, I plug in 4, and I'm doing, so I'm going to rewrite t to the minus 1/2 as 1 over the square root of t. So I've got 1 over the square root of 4 minus negative 2 times 1 over the square root of 1. So that's going to be negative 2 over 2, which is negative 1, plus 2, which is 1. E. Okay. 11. Let f be the function defined by f of x equals the square root of the absolute value of x minus 2 for all x. Which of the following statements is true? Okay, so first of all, I like to think about graphs of these functions. So if you have an idea of what this graph looks like, recommend drawing it. I know that the absolute value of x, looks like a V centered at 0. The absolute value of x minus 2 means that it's shifted to the right 2, and then square rooting kind of like square roots both sides. So it's going to look like this is 2. It's going to look like this, and like this. So first of all, good things to remember is that the absolute value function is not differentiable at the point in the middle. So this function is not going to be differentiable at 2. I do know that. So which of the following statements is true? F is differentiable at 2. That can't be true. F is not continuous. No, that's not true. It's continuous. I can draw it without picking up my pencil. F is continuous but not differentiable at 2. That's a true statement. The limit as x goes to 2 of f of x is 0, so that one's false. X equals 2 is a vertical asymptote of the graph. No, it's not. Okay, so it's definitely A. Number 12. The points -1, -1, and 1, -5 are on the graph of the function y equals f of x that satisfies the differential equation this. Which of the following must be true? Okay, so they've given me a differential equation, and they've told me 2 points, they have 2 points on the solution to that differential equation. So I know I have some function whose derivative satisfies this x squared plus, is equal to x squared plus y. And all the answer choices are about local mins or max or points of inflection, which are things that you figure out by finding if the derivative or if the second derivative are 0. So first I'm going to plug in these points into the derivative. So if I plug in the first point, -1, -1, so I'm evaluating at -1, -1, I get -1 squared minus 1. So -1 squared minus 1. 1 minus 1, that's 0. If I plug it in to the second one, 1, -5, I get 1 squared minus 5. This is 1 minus 5, -4. Okay, so I know that this first one, -1, -1, must be some kind of, is a critical point because the derivative is 0. The next one is not going to be a critical point because the derivative is not 0. I'm thinking about skipping this question, guys, because it's going to take a while to solve this. I think I'm going to skip this one too and come back to it. So 9 and 12, those are ones we got to come back to. Radius of convergence of this power series here. Okay, another BC topic. Radius of convergence, the way you find that, you always use the ratio test. So I'm going to use the ratio test here, which means I need to find, I usually call it L, the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n. And the ratio test will say that if I find this limit L and it's less than 1, then my series will converge absolutely. And if it's bigger than 1, then it would diverge. So I'm going to find this limit L, and I'm going to set it less than 1, and then I'm going to solve for absolute value of x minus 4 to find this radius of convergence. So in this case, this whole entire thing is a sub n. So I'm doing the limit, n goes to infinity, absolute value, a sub n plus 1. So I've got x minus 4 raised to the 2 times n plus 1. Be careful there with parentheses. 3 to the n plus 1. I'm going to multiply by the reciprocal. So 3n over x minus 4 raised to the 2n. All right, now you need to simplify here, which you got to be careful when you do that. The 3n and the 3n plus 1 cancel so that there's just a 3 left on the bottom. So I have a 1/3. The absolute values now are only going to apply to the x minus 4 since 3 is positive. If I factored out this 2n, I get 2n plus 2. So that becomes a 2n plus 2 exponent. The 2n part of that will cancel with the 2n exponent on the bottom. I'm left with an absolute value of x minus 4 squared. Okay, and now so now I'm taking the limit. This is interesting. I'm taking the limit as n goes to infinity, but there's no n's anywhere here. So this limit is just 1/3 x minus 4 squared. I'm dropping the absolute values just because when you square something, it's always positive anyway, regardless of whether you've taken the absolute value. And I want that to be less than 1 so that this thing converges. And then I get, so we'll have x minus 4 squared is less than 3. So then we'll need the absolute value of x minus 4 to be less than the square root of 3. So the radius here is going to be the square root of 3. Let's see. Okay. 14. Almost halfway through time as well. So, okay. Let k be a positive constant. Which of the following is a logistic differential equation? All right, so again, I think this is a BC topic. There's two main types of differential equations. There's the logarithmic and there's the logistic. And so if you don't remember which one's which, skip this problem. If you remember which one it is, then it's going to be a simple problem. So the logistic one is the one that looks like, the logarithmic one is the one that looks like B, I believe. I think this one's the logarithmic. And the logistics one is the one that looks like E, I believe. So this is like either you remember the equation or you don't. So I'm going to go with E. Yeah. Okay. The graph of a differential, these ones are always fun. Okay. The graph of a differentiable function f is shown above. H of x is the integral from 0 to x of f of t. Which of the following statements is true? I don't know if I want to do that one right now. It's not going to be so hard, but yeah, I'm going to skip that one too and come back to it because this first time I'm just trying to maximize my points. So I'm going to not do all the problems that take a really long time. 16, f of x is y equals f of x is the solution to the differential equation dy dx equals x minus y with initial condition f of 1 equals 3. What's the approximation for f of 2 obtained by using Euler's method with two steps of equal length starting at x equals 1? Guys, Euler's method is not very difficult, but it does require that you remember how it works. So if you don't remember the equation for Euler's form or how to do Euler's method, then you should skip this problem. But if you do remember it, it's not going to be that hard of a problem. I'm going to skip it for right now. I do remember it, but I'm going to skip it for the people who don't remember how to do it, and we'll come back to it. X bigger than 0, the power series this converges to which of the following? Again, BC concept, infinite series. We want to know what this converges to. Okay, so this requires you, this is fun. Yeah, okay, so I noticed that, so some Taylor series that I know, or power series that I know, are that, I know that sine of x is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, and so on and so forth. This is why, sine of x is called an odd function, partially because all of the exponents in its Taylor series are odd, if you didn't know that, fun fact. Cosine is called an even function because all of its powers are even powers of x. So we've got x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, and so on and so forth. So I noticed that I've got these 3 factorial, 5 factorial, 7 factorial, which show up in the sine equation. And I also noticed that but then I have positive exponents, even powers of x. So this to me looks like sine of x, but just divided by x. If I divide everywhere through by x on the bottom here, all my exponents would become one smaller. And yeah, so it's got to be sine of x over x. C. It pays to know those Taylor series. 18. The graph of f prime, the derivative of the function of f, consists of 2 line segments and a semicircle as shown in the figure above. If f of 2 is 1, f of negative 5 is what? Okay, great. So this is the derivative. Be careful there. Again, this is a classic kind of use of the fundamental theorem of calculus again. So they give us f of 2, they want to find f of negative 5. I'm going to use that the integral from negative 5 to 2 of the derivative of my function is equal to f of 2 minus f of negative 5. That's the fundamental theorem of calculus at work right there. They give me f of 2. They tell me that's 1. I'm trying to find f of negative 5. And I can find this integral by just finding the area under the curve. So I want the area under the derivative from negative 5 all the way to 2. It's good that they tell me this is a semicircle so I can actually find the area. These triangles, let's see, we've got 1/2 base times height. So 1/2, the base is 1, 2, 3. The height is 2. So that area is 3, this first triangle. Then this is below the x-axis, so be careful when you need to count this as negative in the integral. The area of a circle is pi r squared, so this is half pi r squared, 1/2 pi. My radius here is 2, 1/2 pi 2 squared. So this is 4 pi over 2, 2 pi. And I'm counting that as negative, so I've got my area so far as 3 minus 2 pi. And then the next triangle will be positive area again because it's above, and it looks like it's the same. This is 3, this is 2. So it is area 3, so I'm adding another 3. So I get 6 minus 2 pi for my area. So then I have 6 minus 2 pi equal to 1 minus f of negative 5. So that means f of negative 5 is equal to 1 minus 6 plus 2 pi. So this is negative 5 plus 2 pi. 2 pi minus 5c. Cool. 19. If f is defined by this function, what points x, y in the graph of f have the property that the line tangent to f has a slope of 1/2? Okay, the line tangent is going to have the same slope as the derivative at there, so I need to find the derivative of the function and find where the derivative is 1/2. So I've got f prime of x is equal to, quotient rule. So the way I remember is low d high, low, the derivative of the top is 1, minus high d low, so high is x, the derivative of the bottom is 1, all over the square of what's below. So x plus 2 all squared. All right, so on the top I've got x plus 2 minus x, so I just get 2 over x plus 2 squared. And I want to know where the derivative is 1/2. Cross multiply, I get x plus 2 squared equals 4. Okay, so I need x plus 2 squared to be 4, so I need x plus 2 to be equal to plus or minus 2. Careful when you take the square root there. X has got to be negative 2 plus or minus 2. So that means x is either negative 2 plus 2, 0, or negative 2 minus 2, negative 4. Which of the following points has this property? So there's only one answer that has x equal to 0 and minus 4. So I should be that one. To find the y values, you'd have to plug them back in. If you plug in 0, you do get 0. If you plug in negative 4, you get negative 4 over negative 2, which is 2. Yeah, so I'm going to go with have line tangent have slope 1/2. Yep, that's going to be C again. Okay, we got 23 minutes left. We're on question 20, and so we still got like 10 questions to go, so we got to go pretty fast still here. Okay, this question looks like a U substitution question or maybe a partial fractions integral. Regardless, it looks kind of hard, so I'm going to skip it. 21. The line y equals 5 is a horizontal asymptote to the graph of which of the following functions? Oh, much better question. Okay, horizontal asymptote just means you have to take the limit as x goes to infinity of the function. So I'm saying the limit as x goes to infinity of which of these 5 functions is 5. That's all I want to know. The limit of the first one is not going to end up being 5. It's going to be, well, actually, what would it be? I would rewrite this as sine of 5x over, I want to get a 5x on the bottom because I know that the limit of this one, oh, that says x goes to 0, not as x goes to infinity. Silly me. Okay, nope, not A. Sine doesn't have a limit as x goes to infinity because it just keeps oscillating. 5x goes to infinity. As x goes to infinity here, you go to 0, not to 5. As x goes to infinity, this would go to negative 5. It'd go to 5 over negative 1, negative 5, so it's got to be e, which it does. It goes to 20 over 4, because those are the highest powers of x. Great. 22. The power series this converges at x equals 5. Which of the following must be true? Okay, so yeah, this one's actually not going to be so bad. So the center of this power series, again, this is a BC topic. The center of this power series is 3. So I usually call the center A. And we know that the power series is going to converge within an interval that's symmetric about the center. So if the center is 3 and I know it converges at 5, that means I know that the radius is at least 2. I know it converges at 5. That means the radius is at least 2. So that means it will also converge at 2 and at, well, potentially at 1, but it'll definitely converge at 2. So D is my answer, because I know that my radius, like my interval of convergence, is at least open interval 1 to close interval 5. So it's going to converge at 2. That's a totally conceptual question. 23. P of t is the size of the population at time t. Which of the following differential equations describes linear growth in the size of the population? Linear growth in the size of the population. That would mean that when I integrate this to get P of t is linear in t. So like for this first one, if I solved it, dp dt equals 200. I separate my variables. I get dp equals 200 dt, and then I integrate both of those. I would get p equals 200 t plus c, which is linear in t. So I think it's A. Yeah, that's it. 24. Let f be a differentiable function such that this is true. Oh, which of the following functions could be? Oh, this is interesting. This looks like an integration by parts question. I'm going to skip this one for now. I don't think it'll be that hard, actually, but we're going to skip that because it just looks scary. Okay, yeah, this question is going to be a U substitution. Right away I noticed that, and it's an improper integral, so we got a double there. So improper integrals, remember, we have to rewrite improper integrals as limits. So especially if you have an improper integral on the free response question, you need to make sure you rewrite it as a limit, otherwise you're going to lose some points there. So I'm going to say the limit is t goes to infinity of 1 to t of x e to the minus x squared dx. And so now I need to find each of these for a given t bigger than 1, these integrals, and then I'll take the limit. Okay, so to do that, I'm going to do a U substitution. And so I'm going to pick u to be negative x squared, so that then du is negative 2x dx. I'm doing that because I have a function and its derivative, so this should work out. Again, in my integral I have this x dx, so I want to solve for x dx here, and x dx equals negative 1/2 du. So that's what I'm going to substitute in for x dx. So this integral is going to become the integral from something to something. I'll have to change my bounds of negative 1/2 e to the u du. Figure out the bounds. I started at x equals 1. That when x is 1, u is negative 1. So this is negative 1. And when x is t, this is negative t squared. So I've changed this limit, this integral now, to be this integral. Evaluate that then. So the integral of e to the u is just e to the u. That's nice. So we've got negative 1/2 e to the u. Evaluated from negative 1 to negative t squared. Be careful about these negatives. Plug these in, and we get negative 1/2 times e to the minus t squared minus negative 1/2, so that's a plus 1/2 e to the minus 1. Whew. Okay, and now I want to take the limit of this as t goes to infinity. So now going back to my original question, I'm going to take the limit as t goes to infinity of this integral, which I just found, is, I'm going to rewrite this so maybe it's a little easier to see. There's 1 over e to the t squared plus 1/2 times 1 over e So the only thing that is dependent on t here is the first part. And as t gets big, t squared gets big, e to the t squared goes to infinity, so 1 over that goes to 0. So this whole first part goes to 0, and the rest doesn't depend. So I just get 1 over 2e. 1 over 2e b. Okay, 26. We got 17 minutes left. What is the slope of the line tangent to the polar curve? Oh, goodness, polar. Okay, so this is a BC topic also. So we need to take the derivative with respect to, so slope of the line tangent. So let's do dr d theta. R is a function of theta, so I need to take the derivative with respect to theta. Derivative of 1 is 0. Derivative of 2 sine is 2 cosine theta. And I'm plugging in theta equals 0. So plug in theta equals 0. And I get 2 times cosine of 0. Cosine of 0 is just 1, so this is 2. So the slope of the line tangent is 2. A. That seemed easy. Maybe I made a mistake, but I think that's right. 27. For which of the values of p will both this series and this series converge? Okay. If you're able to identify these series, this isn't going to be a hard question. If you aren't able to identify these series, it's going to be a really hard question. This first problem I noticed is a p series. I know that p series that look like 1 over n to the, I'm actually going to say t. These will converge if t is bigger than 1. So here my t is 2p. So I need 2p to be bigger than 1, which means I need p bigger than 1/2. For the other one, this one is a geometric series. Geometric series converge if, like I said before, if their ratio has absolute value less than 1. So here I need the absolute value of p over 2 to be less than 1, which means I need the absolute value of p to be less than 2. So I'm trying to find where both the absolute value of p is less than 2 and p is bigger than 1/2. I'm going to draw a number line to help me figure that out, because pictures I think always help. So we've got absolute value of p less than 2. That's anywhere from -2 to 2. So I've got -2, let's say this is 0, all the way to 2. That's the first interval, here to here. And then the other one is p bigger than 1/2. So 1/2, and it's bigger than it. So the overlap then is just 1/2 to 2. 1/2 to 2 only c. Yeah, okay, great. 28. Last question of the test, guys. See, I skipped a bunch of questions, so I'm at least seeing all of the problems because I skipped some along the way. You don't want to not read every question. Let g be continuously differentiable with g of 1 equal to 6 and g prime of 1 equal to 3. What is this limit? Oh, this is fun. Okay. So the limit as x, I'm just going to rewrite it. As x goes to 1, integral from 1 to x, g of t dt over g of x minus 6. So first thing when you try to do limits, you try to just plug stuff in, right? So you try and plug 1 in. If you plug 1 in, the top is the integral from 1 to 1 of a function, which is just going to be 0. So the top's going to 0. And the bottom, if you plug in 1, you get g of 1, which they tell me is 6, minus 6, which is also 0. So I have a 0 over 0 limit, which means I should use L'Hopital. And they tell me that it's continuously differentiable, which means I can use L'Hopital. So if I use L'Hopital here, L'Hopital tells me that the limit is going to be the same as the limit of the derivative of the top over the derivative of the bottom. So we're not doing quotient rule, we're just taking the derivative of the top and the derivative of the bottom separately. So the derivative of the top is the derivative with respect to x of this integral from 1 to x g of t dt. This, by the second fundamental theorem of calculus, is just equal to g of x. So on the top we have g of x. On the bottom, we've got the derivative of g of x minus 6, which is just going to be g prime of x, and then the derivative of 6 is 0. So we've got g of x over g prime of x. Now I can try and plug in 1. So this would be g of 1 on the top would be 6, and g prime of 1 on the bottom would be 3. So this is 6 over 3, 2. D. All right, now I have 12 minutes left. I've looked at all the problems. I've got to go back, though, and do a bunch of those ones that I skipped. So let's go back all the way to the top. And 9 was the first one that I skipped. Here, which of the following series converge? Okay, again, BC topic. I've already kind of talked about some of them. So like right away, I noticed that 3 here, I'm looking for highest power of n on the top, highest power of n on the bottom. Highest power of n on the top is just an n. The highest power of n on the bottom is an n cubed. If I multiplied all that out, I get an n cubed. This would simplify to be a 1 over an n squared. So this series is going to act like a 1 over n squared. And the sum of 1 over n squared is going to converge because it's a p series with p equal to 2, which is bigger than 1. So 3 is going to converge, so it's not going to be a or b. Now I have to figure out if the other ones converge. Whenever you see factorials or you see exponential functions, I recommend using the ratio test to see if they converge. So let's do the ratio test quick on number 1. So finding the limit as n goes to infinity of the absolute value of the n plus 1 term, which is 8 n plus 1 over n plus 1 factorial, over a sub n. So I multiply by the reciprocal. This is the limit. N goes to infinity, absolute value of the 8 cancel, so we have an 8 on the top. N factorial, n plus 1 factorial. We need to know that n plus 1 factorial is just n factorial times n plus 1. So on the bottom, I'm just going to get an n plus 1. And then the limit of this as n goes to infinity is always going to be 0, which is always less than 1, which does converge. So 1 is going to converge also. So this is converge. This one converges. Now I have to check 2. Yeah, I still have to check 2. So 2, again, I'm going to use the ratio test. Limit, n goes to infinity, absolute value, n plus 1 factorial over n plus 1 to the 100 times n to the 100 over n factorial. Again, on the top, from the factorial side, we're just going to get the n plus 1. So we have n plus 1. And then we have this n to the 100 over n plus 1 to the 100. The n to the 100, the n plus 1 to the 100, in the limit are going to go to 1 because the highest power of n is going to dominate. Both are n to the 100. Those themselves are going to go to 1. But then I still have this extra n. This is going to go to infinity, which means it's never going to converge. So our answer, this is always going to diverge. Our answer is going to be D. All right, 9 minutes left. I didn't answer, I did 10 and 11. 12, okay. I want to know which of the following is true. I found that -1, -1 was a 0 of the derivative, which means it's a critical point. So it could be a local max or a local min, but 1, -5 can't be, so I know A is wrong. Yeah, okay. Is this a local max or a local min? It's gotta be. So let's find if it's a local max or a local min. How could I do this? I could solve, this is a linear differential equation. So to find if it's a max or, no, this is gonna be tricky. Let's take the second derivative. Second derivative of this. So I'm taking the derivative again of this expression with respect to x to see what I get. I'm going to get 2x plus dy dx. But I know dy dx is x squared plus y. So this is 2x plus x squared plus y. If I plug in 1, -5, what do I get? If I plug in 1, -5, I get 2 plus 1 plus -5. 3 minus 5? 3 minus 5, -2. Okay, well, I was hoping it would give me 0, but it didn't. Points of inflection can only be where the second derivative is 0. In particular, the second derivative has to change sign, has to change from like concave up to concave down. So this one, I plugged it in and I didn't get 0, so it can't be a point of inflection. If I plug in 1, or -1, -1, I would get -2 plus 1 minus 1, which would be -2. Also can't be a point of inflection. So, okay, yeah, so it's either C or D, local min or local max. Oh, I can check the concavity. Yeah, okay, so I've got, I know that -1, -1 is either a local max or a local min, and I just got to figure out which one it is, so I need to know if it's concave up or concave down. So concave down, it'll be a max. Concave up, it'll be a min. I do that by finding the second derivative and plugging it in, which I did up here, and I got -2, which means it's concave down. If it's concave down, then it's a maximum, so C. All right, that was hard. Okay, I don't know what to do. Oh no. Wait, sorry, friends. There we go, got rid of that. Okay, 13 I did, 14, we got 6 minutes. 15, yeah, this one's not too bad. Let's do this. Okay, so h of x, so they give me the graph of f. They tell me h of x is the integral from 0 to x of f. So h of x is defined by the area under the curve of f that I see. Right away, second derivative, the second fundamental theorem of calculus tells me that the derivative, h prime of x, is just, the derivative with respect to x, 0 to x, ft dt is just f of x. So f of x is h prime of x. That's good. And they want me to know something about the values at 6. Looking at the answers, they want me to plug in 6. So I know h prime of 6 is equal to f of 6, which is 0. So I know that one's 0. I also know that h of 6 is the integral from 0 to 6 of this function. So it's the area under the curve from 0 to 6. All of that area is below the x-axis, so it's going to be negative. So I don't know what this is, but I do know that it's negative. So I know that something negative is smaller than 0, so I know h of 6 is less than h prime of 6. Right, so I can probably eliminate a lot of answers using that. Then I know that the second derivative, h double prime of x, will be equal to the first derivative of f. So it's the slope of the function that I see. So h double prime of 6 is f prime of 6. So it's the slope at 6. The slope at 6 is positive slope. So this is smaller than something positive. All right, so I got to find the answer that looks like that. H of 6, h prime of 6, a. Okay. 16, I also skipped. Did I skip any others? I don't know. I don't think I did. Let's do 16. We got 4 minutes. F of x is the solution to this differential equation with this initial condition. Oh yeah, Euler's method. Yeah, okay. So, so Euler's method, let's see. We want to find f of 2. We know f of 1. And we're doing 2 steps of equal length. So if we're going from 1 to 2, 2 steps, that means each step has step size 1/2. So Euler's method will say that I need to do f of 1.5 and then f of 2. Those are my 2 steps. It's going to say f of 1.5 is approximately, I'm going to draw a picture. We've got 1, well, this is not spaced out evenly, but that's fine. This is 1, this is 1.5, this is 2. I'm going to approximate 1 by 5 by going to where I am at 1, I'm at 3, looking and seeing what my slope is there. So I plug in the 0.1 comma 3 into my derivative. I get dy dx there is 1 minus 3, negative 2. My slope there is negative 2. So I'm going to approximate by negative 2. I'm going to keep going to negative 2 until I hit 1.5. I'm going to see what value I'm at. So what was my change in, I need to know my change in y value to find, well, it went down, my slope was negative 2. I'm kind of doing this without just memorizing the formula, I'm just doing it. The slope is negative 2. Yeah, the slope is -2, and my change in x, so that's change in y over change in x. I'm trying to find my change in y. My change in x is 1/2, so -2 equals change in y over 1/2 multiplied by 2, -4 is my change in y. So that means my y started at 3, and I went down 4, so it goes to -1. Now I reevaluate, I do it again. So I plug in 1.5 and 1, and I get 1.5 minus -1, which is 1.5 plus 1, 2.5. So now my slope at this point is now 2.5, going up. And I do the same process. So I've got 2.5 equals change in y over 1/2. This is 5 equals change in y. So I went up 5, so this is going to be, oh, I think I'm doing this wrong because I'm not getting the right answer. This is 4. Okay, well, friends, I forgot how to do Euler's method, so that's good. We have a minute left. We should probably guess because there's no guessing penalty. Which answer is closest to 4? None of them. This one's 5, like something. I don't know, I'm feeling C, so we're just gonna guess that. 17, we got less than a minute. 18, 19, oh, I didn't do 20. Yeah, that one's gonna be hard. Did I do all the others? I didn't do this one. Oh, I think this one's an integration by parts question. Because I see sine and cosine, and another cosine here. So this is like the integral of u dv is equal to uv minus the integral of v du. I know we got 20 seconds left. So if my u was sine x, then my du would be cosine x, which would mean my v would be this 4x cubed. So then my f of x would have to be dv, which would be 12x squared. Oh, but that's not an answer. Dang it. I'm going to guess -x to the 4th. Okay. Wow. All right. See, that was kind of hard. Okay, we're going to go through the answers and see how I did. It's highly likely I made a mistake. I haven't actually taken one of these tests in a long time, so... and when you're under pressure, it's hard, but we'll see how it went. Okay, so going back up to the top, we're gonna see how I did. Number one, E, great. Okay, got number 1 right. Number 2, A. Number 3, B. 4, A. 5, C. Okay, so we're doing good on the first 5. That's good. 6, C. 7 is A. Yep, okay. 8 is C. Good. See, that one was tricky. That's good. I should have probably skipped that to start. But conceptually it wasn't too bad. 9 is D. Good. Okay. 10, E. All right, we're on a roll. 11, A. Okay. 12. Oh yeah, this one was tricky. C. All right. Good. 13. C. 14 is E. All right, so I remembered that. See, these are points we don't want to miss. We've got to memorize these equations of these differential, the different differential equations, because like you get a whole point, the same point that you would get for doing one of those really hard problems just by remembering the formula. 15, A. Good. 16 is C. 17 is C. I guessed. Whoa, I guessed right, guys. That's good. That's a lucky guess. Okay, I should take my own advice and remember what Euler's method is and the formula there. Again, haven't done that in a while, so I didn't remember the formula, but you should. 18 is, oh, I did 18 wrong. That's sad. 18 is A. All right, so we got that one wrong. That's okay. 18 was A. Maybe I multiplied or added wrong or something? I don't know. I think my process was right, so my guess is my computation was not correct. 19 is C. Good. 20 I didn't even guess, but it was also C. So I should have guessed, but I didn't because I ran out of time. 21 is E. 22 is D. 23 A. Good. 24 is I guess in this one. I was close. It was E. 24 E. I was gonna say something about this one. Yeah, I'm actually surprised that 23 was. I'm not surprised that it was A, but I'm surprised that they put the answer first. Often, if they want you to just like check the answers, it's towards the bottom, so that you waste time going through those first few. So that was kind of unexpected. 25 is B. 26 is B. Oh, did something wrong there too. Okay. See, I said I thought this was too easy. I was like, that didn't feel right. Oh, sorry, not 26. 26B, not C. Sorry. My bad. Not B. B. Why did it's 2 instead of 1/2. Okay, alright, well, I have to go back and think about that one. See, I'm not perfect, guys. I'm getting a Ph.D. in math, and I can't even get a perfect score on this test, so don't put too much pressure on yourself here. C for 27. Yep, C for 27 and 28. D. Okay, cool. So how many did I get wrong? Let's see. 1. We got 4. 2. 3. 4. Did I get more than 4? I think I got 4. Okay, 4 wrong. So I got 24 out of 28. Cool. Remember, my goal is to get 30 out of 35, or out of 45. So I got to get, at least 6 more in the next 17. So I got, total 24 out of 28. And then next video, we're going to do the calculator section. All right, thanks for tuning in.